back to the continuing session on the naming of organic compounds containing functional groups. So today we're going to look at the second last of the functional group. We started all the way from alkanes, alkynes, benzene compounds, which we are calling aromatic compounds. Went to alkyl halides. We looked at aromatic halides. You're talking about the ones containing the benzene group and the halogens. And then we looked at alcohols, ethers, aldehydes, ketones. So now we want to look at a molecule or a functional group which is going to be said to be related to ammonia. Now, here I've shown a structure. Just take this small pointing here as a lone pair. So this is a structure, and the blue atomers, the blue ballers, are showing the nitrogen. So, and the white ones are hydrogen. So you can see it is tetrahedral. It being containing only one lone pair, then the bond angles are going to be what? 107.5. We said as for water, because we got two lone pairs, the lone pairs have got a lot of repulsion than one lone pair. So if you've got two lone pairs, then the bond angles between the oxygens, between the oxygen hydrogens is 104.5. But in this case, because we've got only one lone pair, the bond angles are 107.5. So these are tetrahedral. This is ammonia, nitrogen, 3 hydrogens, and then there is the lone pair, tetrahedral structure. So ammonia, amines are going to be related to this structure of ammonia. So that tells you that the lone pair will still be there until it forms an ammonium salt. As you're going to see here, ammonia, they make use of the lone pair to attach another substituent to cause something like an ammonium salt. So also you're going to see amines can also behave in a similar manner, which you're going to see here, whereby the lone pair on the nitrogen can take up an alkyl group to form something like an ion. Yeah. So let us look at the classifications of amines before we come to the names, because the classification is quite important. So the blue ball is nitrogen, the white balls are hydrogen. So if I'm now going to bring in the black ball, you know the black ball is carbon. So what can you see the difference between this and that? Perhaps if I move a little bit further, you'll be able to see here. What you can see is that the two hydrogens are there, but in one case, one of the hydrogens have replaced it with a methyl group or an alkyl group. Now, what you're saying is this: the amines have got classifications, as you're going to see. Also, the other organic compounds have got these classifications. And if you have two hydrogens attached to an atom, in this case, it is nitrogen. That one will be called a primary structure. If you have one hydrogen, that will be called a secondary. If you have no hydrogen attached to that atom, then it will be called a tertiary group. You're going to see the same thing about carbon. If you're dealing with a carbon with two hydrogens, that will be called a primary carbon. If you're dealing with a carbon with one hydrogen, it will be called secondary. If you're dealing with a carbon with no hydrogens, it will be called tertiary. Okay? So this is an amine with whereby the nitrogen has got 2 hydrogen atoms. So this will be called a primary amine. In this case, this alkyl group it's a methyl group, yeah. But this is a primary amine. Now I will show you one in which there is what? There is the nitrogen containing only one hydrogen. So there is an alkyl group, there's an alkyl group. So these are secondary amine, yeah. There's one hydrogen. There's one here which has got three what? three alkyl group, 1, 2, 3. So there is a lone pair here, which currently is not bonded, but later we can put a bond here. But currently, with the nitrogen, if it has 3 bonds, it will be neutral. But if I'm going to add an extra atom, then the nitrogen will have a positive charge. So currently it's got three bonds, so it is neutral. So this is a what? Can you see if I rotate it? This is a tertiary amine. It's got one alkyl group, second alkyl group, a third alkyl group. Three alkyl group, R, and R. What I've done is the second one, like in this one, which is containing two alkyl groups, I've just said R and R prime. It says that R prime and R may be the same. Yeah. What it tells you is that you can have 2 different alkyl groups, but for simplicity, I've just shown 2 similar alkyl groups. There's a CH3 and there's a CH3. So it means that you can have an ethyl group and a methyl group. Yeah, those are going to be different alkyl groups. Yeah. So when you see a prime and a prime, it tells you this one can be different to this one can be different to that one. So like for tertiary, the one which I was showing you is one in which there is R prime and R prime prime, yeah? So this is a tertiary amine. What can you see here? You can also have a case whereby the lone pair of the nitrogen can take up an alkyl group to form a quaternary ammonium salt. Like in this case here, you see how complicated it is. The blue ball is nitrogen, there is a methyl, an alkyl group, another alkyl group, another alkyl group, another alkyl group. So this is a quaternary ammonium salt, yeah? So the nitrogen is positively charged. The lone pair has been taken up, has been filled in, forming a covalent bond between the nitrogen and the alkyl group, yeah? So this is a quaternary ammonium salt. This tertiary amine, 1, 2, 3 alkyl groups. This is a secondary amine, has got a R1 and R2, and then a nitrogen with a single hydrogen. And then there is the primary amine, nitrogen with 2 hydrogens and an alkyl group. Yeah, remember that they are all related to ammonia. Ammonia, primary amine, secondary amine, tertiary amine, and then there is the quaternary ammonium salt, which is more complicated. Yeah, will you remember that? Now, it is possible to name primary, secondary, and tertiary amines, but the names become a bit complicated. For our in our class, we're just going to restrict ourselves to naming primary amines. Yeah. So I sent you a soft copy of the reference or reference textbooks, so you can be able to see how we name secondary amines and also tertiary amines. But for simplicity case, which is in our syllabus, we just restrict ourselves to naming primary amines. Yeah. Yeah. So like in this case, the NH2 here, I've just simplified it to NH2. H2 here, NH2 just means there's the nitrogen with the 2 hydrogens. Yeah. So R in this case is a methyl group. So the amine will be said to be like the important functional group, and then the alkyl group is taken as a substituent. So this one will be called methyl plus the amine as one word. So this will be called methyl amine. In this case, the second one, what can you see? You've got this alkyl group which is complicated, which I'm calling 2-methyl. Can you see? Before, if I didn't have that one, this would have been called a propyl amine. But the propyl group has got a methyl group on carbon number 2. So it will be called 2-methyl propyl, and then the main functional group is an amine. Yeah? Can you see that? Yeah, so we'll be able to look at other functional groups maybe amine containing other functional groups. But now I think this is just showing you how you can be able to add other functional groups. But the point to note is this, that amine is the most important functional group, and the alkyl groups are going to be said to be substituents on the name amine. So for the amines, the name will end with the word amine, and then the substituents are going to be before the name amine, and it will be one word as opposed to two different names. So we're going to stop there, and in a short while we'll look at the last functional group, which we're going to call carboxylic acids. Yeah. So let me move out so that you can be able to see what is on this whiteboard. Yeah, that what we've covered so far. I hope you've really enjoyed how to name these functional groups. Okay. Thank you very much. Okay.